Hi everybody, it's Josh Rappaport with Singing Turtle Press, here to talk to you a little bit more about the LCM shortcut or trick that I taught in my last video. Now, I've gotten some nice emails from people who have told me that they like the trick a lot, but two things. They'd like me to make it even more clear that it's just for two numbers, and secondly, they'd like to see me show why the trick works. So first, let me say that this trick is just for two numbers. There's a different trick or shortcut for three or more numbers, which I will show quite soon. I'll make a video on that very soon. But this trick is just for two numbers. Secondly, you folks want to know why the trick works or see me demonstrate that, so that's what this video is all about. Here's how the trick works or why it works. The trick is based on the following theorem of number theory. It's a branch of mathematics, number theory. The theorem states that if you're given any two natural numbers, and those you remember are the counting numbers, 1, 2, 3, 4, and so on, the positive integers, the product of those two numbers equals the product of the LCM and the GCF of those two numbers. Nice little theorem, quite handy actually. Let's first demonstrate how this theorem works. It's not a proof, it's just a demonstration. And then I'm going to show how this theorem is the basis of the LCM trick. All right, we're going to start over here with our example A. We're going to start with the numbers 8 and 12, and we're going to demonstrate the truth of this theorem for these two numbers. So with 8 and 12, the first thing we do is we take the product of 8 and 12, meaning we say 8 times 12 equals 96. Okay, very good. Next thing we do is we want to get the GCF for these two numbers. Well, 8 and 12 are 4 apart. That means the largest possible number that could go into both is 4, and 4 does go in, so 4 is the GCF. Now, the LCM for 8 and 12 is merely 24. You can check that out yourself. Okay, what do we get when we multiply the GCF by the LCM? Well, you can see 24 times 4, putting the larger number first here, 24 times 4 is simply 96. So the product of the LCM and the GCF equals the product of the two numbers. Very nice. Trick seems to be working. Not trick, rather theorem. Then we go to example B. We're going to use a little bit more larger numbers here. We're going to use 49 and 91. Okay, let's do the same thing. We're going to take the product, 49 times 91, and unbeknownst to you, I'm going to look at my little sheet of paper that says the product is 4,459. Okay, I can't do that in my head. If you can, that's great. In any case, the GCF for these two numbers is actually not hard to see for 49 and 91. 7 goes into both of those, and it's the largest number that does go into both. And the LCM, using my little trick, LCM for these two numbers happens to be 637. Great. All we're going to do now is multiply 637 by 7. I'm going to do that up here. 637 times 7. And I know all you can do this or do it on a calculator, so I'm going to just save some time. It's 4,459. Look at that. It is equal to the product of the numbers. Okay, quick little demonstration that this theorem appears to work. Okay, now, how does this theorem relate to the LCM trick or shortcut that I showed? All right, to understand that, let's go back to that shortcut and remember how it worked. Basically, with a shortcut, what I did was we talked about two numbers, and I'm just going to call them number 1 and number 2. More abstract here. I don't always like using A and B. Sometimes I like putting it in more simple terms. Number 1 and number 2. Also, I love Dr. Seuss, so it's like thing 1 and thing 2. Brings back good memories for me. So what you do is you take number 1 and number 2 and you get the GCF. So we put a little double slash and we would say we would get the GCF. Here I'm just going to call it the GCF. Keep things real simple. You take one of those numbers, let's take number 1, and divide it by the GCF. Okay, and you get a quotient, and you just call that Q for quotient. Then you take that quotient and you multiply it by the other number you'll recall, and what you get is the LCM. That's how the trick works. Now let's analyze this a little bit. The quotient, as you can see right here, is just number 1 divided by the GCF. So underneath the Q for quotient, I'm just going to write number 1 divided by GCF. And we see that that times number 2, and I'm going to write number 2 over 1, equals the LCM. I'm going to write the LCM over 1 too. Sometimes I think it's easier to see the fractions. What this gives us, of course, is that we can just make one big fraction. Number 1 times number 2 divided by the GCF equals the LCM over 1. All we have to do now is cross multiply. We're going to take this proportion basically and we're going to cross multiply, and what we get is the following: number 1 times number 2 equals the LCM times the GCF. So there you have it. That is in essence the same exact thing as what we said here. Given any two natural numbers, the product of the numbers, that's number 1 times number 2, is equal to the product of the LCM and the GCF. LCM times GCF. So you can see that the trick was completely based on this little theorem from number theory. Now I know there are some of you who are still not satisfied, and that is great. Why? It's great because it means you have probing minds. You want to know things at the most basic level, the most root level. You are the radicals of mathematics. And for you folks, and anyone else who's curious, I'm going to do a proof showing why this theorem is true in my next video. So stay tuned.